Today I want to talk about periodic trends. Before I talk about different trends and their properties, I need to review quickly with the periodic table. Now remember, these are groups or families, okay? The rows are energy levels or periods, periodic chart. There are patterns in the periodic table. They're all based on our electron configurations, okay, which we can represent with the Lewis dot diagrams. Now, so let me show you that. First, again, group, notice this as 1A, ignore the A or B, just ignore that. Group 1, okay, this column, okay, this is the family, this is group 1 family. All of them have one valence electron. This is group 2, all have two valence electrons. So group 1 tends to form positive ions. Group 2 tends to form positive 2 ions. Now we're skipping transition metals, okay? Group 1, the alkali metal, group 2, the alkali earth metal. We're skipping transition elements, transition metals, and just focusing on S block, P block. These are said to be main group or representative elements. Representing what? Representing patterns, periodic trends. So carbon, so here's group 3, basically a group of 1, okay, although these also have 3. 3, Roman numeral 3, these 2, group 4, these 3, group 5, group 6, group 7, and then 0 or group 8. Now notice, noble gases don't react because their electron configurations are full. The outermost energy levels are complete. They don't react. These Roman numerals are terribly helpful. We've been using an ion formula sheet, but these Roman numerals, 1, 2, 3, 4, 5, 6, 7, tell us how many valence electrons there are. We can use that to represent the Lewis dot structures, just as I have here. Now, the trends are all based on these electron configurations. And remember, electron configurations are how the electrons, what patterns, how do they move? Where are they located outside the nucleus? They're still part of the atom. Okay, that's what we're looking at. We can describe then all kinds of patterns and it's all based on these electron configurations. They help explain. For example, hydrogen has 1 proton, therefore 1 electron, okay? Helium, again, they're both in the first energy level. Helium has 2 protons, therefore 2 electrons. And so the first energy level, 1s, with helium is full, 1s2. Now, the first energy level is also closest to the nucleus of the atom. The nucleus has protons, electrons are outside. The electrons are negative. Negative electrons are attracted to positive protons. Helium has 2 negative electrons very close to the positive nucleus because it has 2 protons. They're very much attracted, okay? It's very, very, very difficult to remove any of the electrons when they're that close to the nucleus. The same as, and when hydrogen, when it loses an electron, it's basically now just a bare proton. That's all it is. We'll come back to that later when we do acids, okay? Now, so what we're looking at is what are the patterns? There are patterns across the periodic table and down the columns or families. There are patterns. The types of patterns are electronegativity, electron affinity, there's actually first, second, third ionization energy, ionic radii, atomic radii. You can even look at trends in terms of density, boiling point, melting point. Now, you're going to be graphing the trend ionic radii. That's the radius of the ion. For instance, with hydrogen, the radius of the atom, hydrogen, versus the radius of the ion, the positive hydrogen ion. This is going to be bigger. The hydrogen atomic radius is going to be greater than the hydrogen ion radius because it's lost that electron. Okay? It's going to be a smaller radius. But you're going to graph that, okay? We could also graph, and I put on there, pattern for specifically electronegativity. This is basic. Electronegativity is an important property. It gives us a lot of information about how well does it attract electrons. And it's a scale of 1 to 4, actually 0 to 4, because some of these are a little less than 1. They're like 0.7, 0.8. What we see is for electronegativity is it decreases as we go down the families, and it increases as we go across the period. So you're going to be doing a periodic trend. Pick one, okay? There's data in that packet that I have, 6.1, okay? There's data in your book. So what you're going to do is pick a property. You can use one from the internet as long as you have the information. And what I want you to do is model it. I want you to create a 3D model, put one online. I'll go ahead and put that back online under this video. And I want you to show me, using straws, toothpicks, etc., what the pattern is. And we need to have the pattern as we go down the columns and families and as we go across the periods or rows. That's it.